welcome to my channel. My name is Orion Wells and you're watching Cosmos. Tonight we embark on a journey to the edge of our solar system, to a world shrouded in mystery and ice. Pluto. Discovered in 1930, Pluto has captivated our imaginations for nearly a century. It was once considered our ninth planet, a distant and enigmatic member of our cosmic family. Over time, our understanding of Pluto and the universe has evolved. This evolution led to Pluto's reclassification as a dwarf planet, a decision that sparked debate and ignited our curiosity. Join me as we delve into the story of Pluto, from its initial discovery to the groundbreaking revelations of the New Horizons mission. Our story begins in the early 20th century. Astronomers were searching for a mysterious Planet X, a hypothetical giant believed to be lurking beyond Neptune. This search led a young astronomer named Clyde Tombaugh to the Lowell Observatory in Flagstaff, Arizona. Tombaugh's dedication and meticulous observations paid off. On February 18, 1930, he identified a faint point of light moving against the backdrop of stars. This point of light, a mere speck in the vastness of space, would soon become known as Pluto. The discovery of Pluto sent ripples of excitement through the scientific community and captured the world's imagination. Named after the Roman god of the underworld, Pluto, with its distant and icy nature, seemed to fit its namesake. As we learned more about Pluto, its peculiarities began to surface. Its small size, unusual orbit, and the discovery of other similar objects in the distant reaches of our solar system challenged our understanding of what defines a planet. This challenge culminated in 2006 when the International Astronomical Union reclassified Pluto as a dwarf planet. While this decision sparked debate, it also highlighted the dynamic nature of scientific discovery. Our exploration of Pluto, however, was far from over. In 2006, just months before Pluto's reclassification, NASA launched the New Horizons spacecraft. This ambitious mission, a testament to our thirst for knowledge, would forever change our understanding of this distant world. Before we delve into the specifics of Pluto's discovery, it's important to understand the scientific landscape of the early 20th century. Astronomers had been grappling with irregularities in the orbits of Uranus and Neptune, the outermost known planets at the time. These irregularities, they believed, hinted at the presence of another celestial body, a massive object lurking beyond Neptune's orbit, exerting its gravitational influence. This hypothetical object, dubbed Planet X, became the focus of intense astronomical investigation. The search for Planet X was a daunting task, requiring meticulous observations and complex calculations. Astronomers around the world were eager to make the discovery, to etch their names in the annals of space exploration. The Lowell Observatory in Flagstaff, Arizona, became a focal point for this celestial pursuit. Percival Lowell, the observatory's founder, had dedicated a significant portion of his life and resources to the hunt for Planet X. Lowell's calculations and predictions laid the groundwork for what would become a pivotal moment in astronomical history. However, Lowell's dream of finding Planet X would remain unfulfilled. He passed away in 1916, but his legacy and the search for the elusive planet continued. The observatory, carrying the torch of Lowell's ambition, pressed on, determined to unravel the mysteries of our solar system's outer reaches. Enter Clyde Tombaugh, a young man from Kansas with a passion for astronomy. Tombaugh's journey to the Lowell Observatory is a testament to his dedication and the power of perseverance. Lacking a formal college education, Tombaugh honed his skills by building his own telescopes and meticulously studying the night sky. His detailed drawings of Jupiter and Mars, a testament to his observational prowess, caught the attention of the Lowell Observatory. In 1929, Tombaugh was offered a position at the observatory, tasked with the daunting challenge of picking up where Lowell had left off. Little did he know that he was about to make history. February 18, 1930, a moment in history. Tombaugh's days were spent meticulously examining photographic plates, comparing images of the night sky taken days apart. The process was painstaking, requiring incredible patience and a keen eye for detail. He used a device called a blink comparator, which allowed him to rapidly switch between two images of the same section of the sky. On February 18, 1930, while examining plates taken in January of that year, Tombaugh noticed something extraordinary. A faint point of light, barely discernible amidst a sea of stars, appeared to shift position ever so slightly between the two images. This subtle shift, a telltale sign of a celestial object moving against the backdrop of stars, sent a jolt of excitement through the young astronomer. Why Pluto? The story behind the name. The discovery of this distant world, later confirmed to be the object we now know as Pluto, was a momentous occasion. The news spread like wildfire, captivating the public imagination and igniting a debate within the scientific community about its classification. But before we delve into that, let's explore how Pluto got its name. The honor of naming a celestial object traditionally falls upon its discoverer. Tombaugh, thrust into the limelight, received suggestions from around the world. The name Pluto emerged from the flurry of proposals suggested by Venetia Burney, an 11-year-old schoolgirl from England. The realm of the underworld. Venetia, fascinated by mythology and astronomy, proposed the name Pluto, after the Roman god of the underworld. The name seemed fitting for a world residing in the cold, dark depths of our solar system. Pluto, often depicted as a shadowy figure, ruler of the realm beyond the living, mirrored the newfound world's distant and enigmatic nature. The name resonated with astronomers at the Lowell Observatory, and on May 1, 1930, the world officially welcomed Pluto into our cosmic neighborhood. Little did anyone know that this distant world, shrouded in mystery and ice, would continue to captivate our imaginations and challenge our understanding of the universe for decades to come. A distant world, unveiling Pluto's mysteries. With Pluto's discovery, our understanding of the solar system expanded, reaching into the cold and dimly lit realms beyond Neptune. But Pluto, shrouded in distance and cosmic dust, held its secrets close. Early observations, hampered by technological limitations, could only reveal so much about this newly found world. We knew it was there, a faint point of light moving against the backdrop of stars, but its true nature remained elusive. Was it a rocky world like our own, or something altogether different? What was its surface like? Did it possess an atmosphere? These questions lingered, fueling our curiosity and driving us to develop new technologies to unlock Pluto's secrets. Size matters. Pluto in perspective. One of the initial revelations about Pluto, and one that would later play a role in its reclassification, was its surprisingly small size. Early estimates pegged Pluto as being roughly the size of Mars. However, as our observational techniques improved, it became clear that Pluto was significantly smaller than initially thought. Today we know that Pluto has a diameter of just 2,377 kilometers, making it smaller than our own Moon. To put that into perspective, if Earth were the size of a nickel, Pluto would be about the size of a grain of popcorn. This realization that Pluto was significantly smaller than any other planet in our solar system raised questions about its true nature and its place among the celestial bodies orbiting our Sun. Despite its small size and distance from the Sun, Pluto surprised astronomers with the discovery of its atmosphere. In the late 1980s, astronomers observed Pluto passing in front of a distant star. During this event, known as a stellar occultation, they noticed that the star's light dimmed gradually, rather than abruptly, as Pluto passed in front of it. This gradual dimming provided evidence of a thin atmosphere surrounding Pluto, scattering starlight before the dwarf planet itself blocked the star completely. This atmosphere, while incredibly thin compared to Earth's, hinted at a world more dynamic than previously thought, a world where atmospheric processes might be shaping its surface. As our telescopes became more powerful, and with the advent of space-based observatories like the Hubble Space Telescope, we began to discern surface features on Pluto. These observations revealed a world of stark contrasts, a landscape sculpted by extreme temperatures and a complex geological history. Pluto's surface is covered in various types of ices, including nitrogen, methane, and carbon monoxide. These ices, rather than behaving like water ice on Earth, flow and sublimate, transitioning directly from solid to gas in Pluto's weak gravity and frigid temperatures. This creates a dynamic surface where glaciers flow, plains are reshaped, and mountains rise. One of the most striking features observed on Pluto's surface is a large, heart-shaped region informally named Tombor Regio, a fitting tribute to Pluto's discoverer. This region, captured in stunning detail by the New Horizons spacecraft, has captivated scientists and the public alike. The western lobe of Tombor Regio, known as Sputnik Planitia, is particularly intriguing. It's a vast, smooth plain that appears to be relatively young in geological terms, suggesting ongoing geological activity. Scientists believe Sputnik Planitia might be a giant impact basin that has been filled with nitrogen ice, creating a vast frozen sea. Pluto is not alone in its journey around the Sun. It's accompanied by 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon, the largest of Pluto's moons, is so large relative to Pluto that the two bodies are often considered a binary system, with their center of mass located outside of Pluto itself. Charon's surface is a study in contrasts, with a reddish north polar region informally named Mordor Macula, hinting at the presence of complex organic molecules called tholins. The other moons, smaller and less well understood, add to the intrigue of the Plutonian system, offering glimpses into the processes that shaped this distant corner of our solar system. A dance of extremes, Pluto's orbit. Pluto's orbit around the Sun is another characteristic that sets it apart from the 8 major planets. Unlike the relatively circular orbits of the planets, Pluto's orbit is highly elliptical, taking it on a wild ride that varies dramatically in distance from the Sun. At its closest point, Pluto ventures within the orbit of Neptune, experiencing a brief period of relative warmth. However, for most of its 248-year journey around the Sun, Pluto remains in the frigid depths of the outer solar system, its surface locked in a deep freeze. Pluto, a window into the early solar system. Despite its reclassification as a dwarf planet, Pluto remains a captivating world, a celestial time capsule offering invaluable insights into the early solar system. Its composition, its moons, and its position within the Kuiper Belt provide clues about the conditions that prevailed during the solar system's formation. By studying Pluto, we're not just exploring a single distant world. We're peering back in time, uncovering secrets about the very origins of our cosmic neighborhood, and gaining a deeper appreciation for the vast and diverse tapestry of our universe. A shift in perspective, redefining planet. For over 70 years, Pluto held a secure place in our collective imagination as the 9th planet, a distant and icy world at the edge of our solar system. However, as our understanding of the universe expanded, so too did our awareness of the vast diversity of celestial objects that populate our cosmic neighborhood. This newfound knowledge, fueled by technological advancements and groundbreaking discoveries, forced us to confront a fundamental question. Well, what exactly defines a planet? This question, seemingly simple on the surface, ignited a debate within the scientific community, a debate that would ultimately lead to a profound shift in our understanding of the solar system and Pluto's place within it. In 2006, the International Astronomical Union, the organization responsible for defining astronomical objects and their classifications, convened a meeting in Prague to address the growing debate surrounding the definition of a planet. This meeting, attended by astronomers from around the world, became a pivotal moment in the history of planetary science. After much deliberation and heated discussion, the IAU voted to adopt a new definition of a planet, a definition that would have profound implications for Pluto. This decision, far from being arbitrary, was based on years of scientific observation, data analysis, and a growing understanding of the complex dynamics of our solar system. Criteria for planethood, 3 rules to rule them all. The IAU's new definition of a planet established 3 key criteria that a celestial body must meet to be considered a full-fledged planet. These criteria, while seemingly straightforward, are rooted in complex orbital mechanics and the gravitational interplay between celestial bodies. First, a planet must orbit the Sun. This criterion distinguishes planets from moons, which orbit planets, and other objects, like comets, that might have more eccentric orbits. Second, a planet must be massive enough for its own gravity to pull it into a nearly round shape. This criterion ensures that a planet is in hydrostatic equilibrium, meaning its internal pressure balances the inward pull of its gravity. Pluto's shortcomings, a matter of orbital dominance. The third and final criterion, the one that ultimately led to Pluto's reclassification, is where things get a bit more complex. The IAU's definition states that a planet must have cleared the neighborhood around its orbit. In other words, a planet must be the gravitationally dominant object in its orbital region, having swept up or scattered away most other objects in its path. This is where Pluto falls short. While Pluto orbits the Sun and is massive enough to be nearly round, its orbit intersects with the orbits of other objects in the Kuiper Belt, a vast region beyond Neptune populated by icy bodies and dwarf planets. This means that Pluto shares its orbital neighborhood with other objects of comparable size, rather than being the gravitationally dominant body in its region. Dwarf planets, a new category emerges. The IAU's decision to reclassify Pluto did not relegate it to the status of a mere space rock. Instead, it led to the creation of a new category of celestial objects, dwarf planets. Dwarf planets like Pluto meet the first 2 criteria for planethood. They orbit the Sun and are nearly round, but they have not cleared their orbital neighborhoods. This new category acknowledged the diversity of objects in our solar system and provided a more nuanced way to classify them. Pluto, far from being unique in its reclassification, joined the ranks of other dwarf planets, including Eris, Haumea, and Makemake, all residing in the distant reaches of the solar system. The debate rages on scientists, and the public weigh in. The IAU's decision to reclassify Pluto sparked a wave of debate and discussion, both within the scientific community and among the general public. Some astronomers argued that the new definition was too restrictive, that it excluded objects like Pluto that clearly exhibited characteristics of planets. Others supported the IAU's decision, arguing that it brought clarity and consistency to the classification of celestial objects. The public too had strong opinions, with some lamenting Pluto's demotion and others embracing the opportunity to learn more about the dynamic nature of scientific discovery. Pluto's legacy beyond the definition. Despite the debate, one thing is certain: Pluto's scientific and cultural significance extends far beyond its classification. Whether we call it a planet, a dwarf planet, or simply a fascinating world at the edge of our solar system, Pluto continues to captivate our imaginations and inspire further exploration. The New Horizons mission, which flew past Pluto in 2015, provided an unprecedented glimpse into this distant world, revealing a surprisingly complex and dynamic landscape. Pluto's heart-shaped region, its nitrogen glaciers, and its towering mountains serve as a testament to the incredible diversity of worlds that exist beyond our own. A universe of wonders, embracing the diversity of worlds. The story of Pluto is ultimately a story about the ever-evolving nature of scientific understanding. As we develop new technologies and gather more data, our perspectives shift, and our definitions must adapt to accommodate new discoveries. The reclassification of Pluto, while initially met with resistance, has ultimately enriched our understanding of the solar system and the universe beyond. It has opened our eyes to the vast diversity of worlds that exist, each with its own unique story to tell. Section 1. Beyond the Known Planets, venturing into the Kuiper Belt. Our journey to understand Pluto's place in the solar system takes us beyond the familiar 8 planets, beyond the orbit of Neptune, to a region once shrouded in mystery and speculation, the Kuiper Belt. This vast and frigid region, named after Dutch-American astronomer Gerard Kuiper, who first proposed its existence in 1951, represents a significant shift in our understanding of the solar system's structure and evolution. For centuries, our view of the solar system was confined to the 8 major planets, from Mercury to Neptune. Beyond Neptune, it was thought to be a realm of emptiness, a vast and desolate expanse, punctuated only by the occasional comet venturing inwards from the distant Oort cloud. However, the discovery of Pluto in 1930 hinted at the possibility of a more complex and populated region beyond the known planets. Section 2. A realm of ice and rock. The Kuiper Belt's composition. The Kuiper Belt, we now know, is a vast torus or donut-shaped region extending from roughly 30 to 55 astronomical units from the Sun. This distant region is teeming with a variety of celestial objects, each holding clues to the early solar system. 1 astronomical unit is the average distance between the Earth and the Sun, approximately 93 million miles. This unit helps us grasp the immense scale of the Kuiper Belt's reach. Within this vast expanse, countless icy bodies, remnants from the early solar system, orbit the Sun in a slow and stately dance. These objects have remained largely unchanged for billions of years. Unlike the rocky, terrestrial planets of the inner solar system or the gas giants that dominate the outer regions, the Kuiper Belt is populated by objects primarily composed of ices. These icy bodies are distinct from the rocky and gaseous worlds we are more familiar with. These ices are not limited to water ice, but also include frozen methane, ammonia, and other volatile compounds that would be gaseous closer to the Sun. The cold temperatures in the Kuiper Belt allow these substances to remain solid. These icy bodies, ranging in size from small, kilometer-sized objects to dwarf planets like Pluto, represent a treasure trove of information about the conditions that prevailed during the solar system's formation. Studying them can provide insights into the processes that shaped our cosmic neighborhood. Pluto's reclassification as a dwarf planet in 2006, while initially met with resistance, ultimately solidified its place as a prominent member of the Kuiper Belt. Its size, composition, and orbital characteristics align closely with other known Kuiper Belt objects, suggesting a shared origin and evolutionary history. Pluto's orbit, while highly elliptical, is typical of many Kuiper Belt objects. These objects, often referred to as trans-Neptunian objects, or TNOs, are influenced by Neptune's gravity, which can nudge them into resonant orbits, where their orbital periods are in a specific ratio with Neptune's orbital period. Pluto, for example, is in a 2-to-3 resonance with Neptune, meaning that for every 2 orbits Pluto makes around the Sun, Neptune completes 3. The Kuiper Belt is not just a collection of icy objects, it's a cosmic shooting gallery, a region where collisions and gravitational interactions have shaped the solar system we see today. These collisions, occurring over billions of years, have left their mark on the surfaces of Kuiper Belt objects, creating craters, fractures, and other geological features. These collisions also play a crucial role in delivering comets to the inner solar system. Gravitational interactions between Kuiper Belt objects or close encounters with Neptune can perturb their orbits, sending them on trajectories that bring them closer to the Sun. As these icy bodies approach the Sun, they heat up, releasing gas and dust that form the characteristic tails of comets. The Kuiper Belt, with its vast collection of icy objects, represents a time capsule from the early solar system. These objects, formed in the cold and distant reaches beyond the giant planets, have remained relatively unchanged for billions of years, preserving clues about the conditions that prevailed during the solar system's formation. By studying the composition, size distribution, and orbital characteristics of Kuiper Belt objects, astronomers can piece together a more complete picture of the solar system's early history. These studies provide insights into the processes that led to the formation of planets, the distribution of elements within the solar system, and the conditions that might have given rise to life on Earth. The discovery and subsequent exploration of the Kuiper Belt have profoundly impacted our understanding of the solar system and our place within it. What was once thought to be a relatively empty region beyond the known planets has been revealed to be a dynamic and complex environment, teeming with icy objects that hold clues to our cosmic origins. Furthermore, the Kuiper Belt's existence has expanded our perspective on the diversity of planetary systems. As we discover more exoplanets, planets orbiting other stars, we find that many systems exhibit structures similar to the Kuiper Belt, suggesting that such regions might be a common feature of planetary system formation. The launch of the New Horizons spacecraft on January 19, 2006 marked the beginning of a daring mission to explore the last unexplored world in our solar system, Pluto. This ambitious endeavor, a testament to human ingenuity and our insatiable thirst for knowledge, promised to revolutionize our understanding of this distant and enigmatic world. The New Horizons mission, a cornerstone of NASA's New Frontiers program, was conceived to answer fundamental questions about Pluto's geology, surface, composition, atmosphere, and its system of moons. The spacecraft, traveling at speeds exceeding 36,000 miles per hour, would become the fastest spacecraft ever launched from Earth, embarking on a journey of over 3 billion miles to its distant target. The New Horizons spacecraft, about the size of a grand piano, is a marvel of modern engineering. Equipped with 7 scientific instruments, including cameras, spectrometers, and plasma instruments, it carries the hopes and dreams of countless scientists, engineers, and space enthusiasts, eager to unlock Pluto's secrets. To survive the long journey and the harsh conditions of the outer solar system, New Horizons was designed with redundancy in mind. Its systems, including its power supply, communications, and propulsion systems, were meticulously engineered to withstand the rigors of space travel and the extreme cold of the Kuiper Belt. The spacecraft's power source, a radioisotope thermoelectric generator, converts the heat from decaying plutonium into electricity, providing a reliable source of power for its instruments and systems throughout its long journey. A long journey begins, 9 years to Pluto. After a successful launch and a gravity assist from Jupiter in 2007, which shortened its travel time by several years, New Horizons embarked on its long and lonely journey to Pluto. This maneuver was crucial, as it provided the spacecraft with the necessary speed to reach the distant dwarf planet in a reasonable time frame. The spacecraft, guided by sophisticated navigation systems, spent the next 9 years traversing the vast emptiness of the solar system, covering billions of miles. It was a journey filled with both anticipation and uncertainty, as the team on Earth awaited the first close-up images of Pluto, its instruments collecting data on the solar wind, the interplanetary magnetic field, and cosmic rays, providing valuable insights into the environment of the outer solar system and other phenomena it encountered along the way. These observations were critical for understanding the space weather conditions that the spacecraft would face. During its journey, New Horizons remained in contact with Earth, sending back data and receiving commands from Mission Control at the Johns Hopkins Applied Physics Laboratory in Maryland. This constant communication was vital for the success of the mission. The dedicated team of engineers and scientists worked tirelessly to ensure the spacecraft systems were functioning correctly and to make any necessary adjustments. However, due to the vast distances involved, communication with the spacecraft was subject to significant delays. This meant that real-time control was impossible, and the team had to plan meticulously. Signals from Earth, traveling at the speed of light, took over 4 hours to reach New Horizons, making every command a carefully considered decision, and commands sent to the spacecraft took an equal amount of time to arrive. This delay required the mission team to anticipate and solve potential issues well in advance, ensuring the spacecraft's successful journey to Pluto. Pluto in high definition. On July 14, 2015, after a journey of over 9 years and 3 billion miles, New Horizons made its closest approach to Pluto, flying within 7,800 miles of its surface. This historic flyby, a testament to the dedication and perseverance of the New Horizons team, provided an unprecedented glimpse into this distant and enigmatic world. During its closest approach, New Horizons instruments worked tirelessly, capturing high-resolution images, mapping its surface composition, and studying its atmosphere and its system of moons. The spacecraft's cameras, including the Long-Range Reconnaissance Imager, or LORRI, and the Ralph instrument, revealed a world of surprising complexity and diversity, a stark contrast to the blurry images that had previously defined our view of Pluto. Unveiling a hidden world. Key discoveries from New Horizons. The data returned by New Horizons during its flyby of Pluto has revolutionized our understanding of this distant world. The spacecraft's instruments revealed a world far more geologically active than previously thought, with towering mountains of water ice, vast nitrogen glaciers, and a complex, layered atmosphere. One of the most surprising discoveries was the presence of a vast, heart-shaped region on Pluto's surface, informally named Tombaugh Regio, after Pluto's discoverer. This region, composed of nitrogen, methane, and carbon monoxide ices, exhibits a wide range of geological features, including smooth plains, rugged mountains, and evidence of cryovolcanism, where icy material erupts from beneath the surface. Section 6. Beyond Pluto. New Horizons explores the Kuiper Belt. After its successful flyby of Pluto, New Horizons continued its journey deeper into the Kuiper Belt. In 2019, the spacecraft conducted a flyby of a smaller, more distant Kuiper Belt object called Arrokoth, formerly known as Ultima Thule. This encounter, the most distant flyby ever conducted by a spacecraft, provided further insights into the diversity of objects in the Kuiper Belt and the processes that shaped the early solar system. New Horizons, now billions of miles from Earth, continues to explore the Kuiper Belt, its instruments collecting valuable data on the solar wind, the interplanetary magnetic field, and the distribution of dust and gas in this distant region. The spacecraft's mission, extended indefinitely, promises to further expand our understanding of the solar system's outer reaches and the processes that shaped our cosmic neighborhood. Pluto. A universe of discoveries. From a tiny speck of light captured on a photographic plate to a world of stunning complexity revealed by New Horizons, Pluto's story is one of scientific discovery, technological advancement, and the boundless capacity of human curiosity. We've traversed billions of miles and decades of research to unravel Pluto's secrets, from its discovery by Clyde Tombaugh to its reclassification as a dwarf planet and the groundbreaking revelations of the New Horizons mission. Each step of this journey has reshaped our understanding of the solar system and our place within it. Pluto, once considered the ninth planet, now stands as a prominent member of the Kuiper Belt, a vast and icy realm beyond Neptune. Its reclassification, though initially met with resistance, has ultimately broadened our perspective on the diversity of worlds that populate our solar system and the universe beyond. Pluto's heart-shaped region, its towering mountains, its nitrogen glaciers, and its system of moons all serve as a testament to the incredible variety of landscapes and celestial bodies that exist beyond our own planet. Pluto's story reminds us that there is always more to discover, that the universe is full of surprises, and that our journey of exploration is far from over. Keep exploring. As we conclude our exploration of Pluto, let's take a moment to appreciate the dedication, ingenuity, and perseverance of the countless scientists, engineers, and technicians who made this journey possible. Their tireless efforts and unwavering commitment have pushed the boundaries of what we thought was achievable, turning dreams into reality. From the early pioneers who first dreamed of reaching beyond our planet to the teams behind missions like New Horizons, their work has expanded our horizons and inspired generations to come. These visionaries laid the groundwork for the incredible advancements we see today, and their legacy continues to drive us forward. As we continue to explore our solar system and beyond, we carry with us the lessons learned from Pluto, a reminder that even the most distant and seemingly insignificant objects can hold profound secrets, waiting to be unlocked by the power of human curiosity and the relentless pursuit of knowledge. Each discovery fuels our desire to learn more, to push further, and to never stop exploring. Keep exploring. Thank you for joining me on this journey to the edge of our solar system. Your curiosity and passion for discovery are what make these adventures possible. If you enjoyed this video and want to explore more wonders of the cosmos, be sure to like and subscribe to my channel for more. Together, we can continue to uncover the mysteries of the universe and share in the excitement of each new discovery. Until next time, keep looking up and keep exploring. The universe is vast and full of wonders, just waiting for us to discover. As we look to the future, the journey to Pluto and the Kuiper Belt is far from over. With each passing year, our technological prowess grows, and the dreams of new missions become ever more tangible. Future robotic missions to Pluto are already being planned, aiming to delve even deeper into its mysteries and send back more detailed data than ever before. Imagine landers and rovers traversing the icy plains of Pluto, analyzing its surface composition and uncovering the secrets hidden within its frozen heart. But perhaps the most exciting prospect lies in the potential for manned missions. While still a distant dream, the idea of astronauts setting foot on Pluto or exploring the Kuiper Belt is no longer confined to the realm of science fiction. Such missions would require groundbreaking advancements in space travel technology, including more efficient propulsion systems, advanced life support, and radiation protection. The challenges are immense, but so is the human spirit of exploration. Technological advancements in artificial intelligence, robotics, and materials science will play a crucial role in making these missions a reality. Autonomous systems capable of making real-time decisions will be essential for navigating the harsh and unpredictable environments of the outer solar system. Innovations in spacecraft design and propulsion could shorten travel times, making these distant worlds more accessible. As we stand on the cusp of this new era of exploration, one thing is clear: The spirit of curiosity and the drive to explore the unknown will continue to propel us forward. The future of space exploration holds boundless possibilities, and with each step, we come closer to uncovering the secrets of our universe. Thank you for joining me on this incredible journey. If you're as excited about the future of space exploration as I am, don't forget to like, subscribe, and hit the notification bell for more updates on the latest discoveries and missions. Together, let's keep pushing the boundaries of what we know and venture into the great unknown. Until next time, keep looking up and keep exploring. As we close our exploration of Pluto, it's crucial to reflect on its cultural impact, particularly following its reclassification as a dwarf planet. This change sparked a wave of public reactions, from curiosity to controversy and even nostalgia, when the International Astronomical Union redefined Pluto's status in 2006. The news resonated far beyond scientific circles. For many, Pluto was more than a celestial body. It was a cherished part of our solar system family. The decision to demote Pluto ignited passionate debates, with some feeling a sense of loss and others welcoming the advancement of scientific understanding. The media and literature quickly picked up on this emotional resonance. Pluto's reclassification has been referenced in countless TV shows, movies, and books. For instance, in the popular TV show The Big Bang Theory, characters humorously lament Pluto's demotion, reflecting a sentiment shared by many fans. Children's books and educational materials grappled with explaining this change to young minds, often portraying Pluto as an underdog in the cosmic narrative. Music artists and poets have also found inspiration in Pluto's story, using it as a metaphor for feeling outcast or misunderstood. This reclassification has humanized the distant dwarf planet, making it a symbol of resilience and curiosity. Public campaigns and petitions emerged, with people advocating for Pluto's reinstatement as a planet. These movements highlight the deep emotional connection people have with our solar system's former ninth planet. It underscores how scientific decisions can ripple through society, affecting not just our understanding of the cosmos, but also our collective imagination. In essence, Pluto's journey from planet to dwarf planet and its subsequent cultural impact remind us that our quest for knowledge is intertwined with our human stories. The reclassification of Pluto has not diminished its allure. Rather, it has amplified our fascination, prompting us to look deeper into the mysteries of our universe. Thank you for joining us on this incredible journey through Pluto's past, present, and future. If you enjoyed this exploration, please like, subscribe, and hit the notification bell for more cosmic discoveries. Together, let's continue to embrace the wonders of our universe and celebrate the spirit of exploration. Until next time, keep looking up and keep exploring. As we wrap up our deep dive into Pluto's fascinating story, let's take a moment to summarize the key points we've explored. We've journeyed through Pluto's discovery, its initial classification as the ninth planet, and its eventual reclassification as a dwarf planet by the International Astronomical Union in 2006. We've delved into the public's emotional response to this change, the cultural impact that followed, and how Pluto has become a symbol of resilience and curiosity in our collective imagination. We've also ventured into the mysteries of Pluto's atmosphere, its unique orbit, and the intriguing features of its landscape and moons. We've examined the broader Kuiper Belt, where Pluto resides, and how studying this region offers invaluable insights into the early solar system. The New Horizons mission has provided us with unprecedented high-definition images and key discoveries, further fueling our fascination with this distant world. As we look to the future, we anticipate more missions to Pluto and the Kuiper Belt, promising even more astonishing discoveries and deepening our understanding of the cosmos. If you've enjoyed this cosmic journey and want to stay updated with the latest discoveries in space exploration, please like, subscribe, and hit the notification bell. Your support helps us continue to bring you fascinating content about the wonders of our universe. Until next time, keep looking up and keep exploring.